To this video, and we're going to discuss about vector equation of a line. So before I proceed and give you um, the form of the equation of a line, I would like to start with a real example, so we would be able to make a generalization later after this one. So let's say that I have this point, and this point is 1 comma 1, and I have this point here, and this point is negative 3 comma 2, and what am I looking for is the equation of a line. Alright, I am looking for that vector equation of a line. So let's say that this is my point A and that is my point B. So just for you to be able to visualize it, imagine that there is a person. So imagine that there is a person, and that person, this little boy, okay, would like to go and walk along that line. So we'd like to walk along the line. So, and he is coming from the origin. So he's coming from here, from the origin. So you are giving him an instruction on how can he go to that line. So basically what you can say is that, okay, for you to be able to go to that line, you must be on the line. So either you go to point B, or you go to point A. So the boy will decide, am I going to A or am I going to B? And please take a look that this OA is the vector negative 3, 2, and B is the vector 1, 1, 1, 1. Okay? So let's say the boy said, okay, I want to go to A. So the boy now will walk to A. So the boy will walk to A. Let me just delete this one because I don't need it. So he will go to OA. When he landed into A, for him to be able to go to the yellow line, he needs to follow certain direction. And what is that direction that he needs to follow? He needs to go along, for example, here in this direction AB. Okay? So, meaning he needs to follow that direction AB. So let's say that he will walk from OA. He will walk, okay? He will walk along that AB, that vector AB. So where would he land? So OA, from O he goes to A, and then from A he walks to B. So therefore he will land at this point. Okay? So basically this boy here could land to any point on the line. So for example, I have another vector. So let's say the vector OA. So he goes to OA, but instead of walking as much as AB, he will just walk half of that vector AB. Only half. Okay? Only half. So if he will walk half of AB, so that's going to be on the middle of A and B. So basically the boy will be on this position. Okay? In this position here. I would say this is my P2. Okay, P2. What about if the boy says, hey, what if I walk 2 times of my AB? 2 times of my AB, right? So because 2 times of the AB, therefore he will walk twice as much as the AB, twice as much. So therefore the boy will land on this position, okay? Because twice as much. Well, it doesn't look, but that's actually the concept. So there is a boy who's walking, who wants to walk on the line. So what he needs to do is to land first to this point A, and then from there he will follow certain direction AB. So the AB, this AB is the direction that he will walk through. Okay? So let's say for example, he says, what about if I walk 1/4 only of AB? So OA plus 1/4 of AB. So again, he will land in this part. Okay, so let's say that is not the point 4 because this is your point 3. What about if he says, okay, if I will negative 1/4 of my vector AB? Oh, so meaning from A, you want negative 1/4 of vector AB, so that's going to be on the other direction because your AB is going down from A to B, right? So therefore, negative of AB is the BA direction. So he will land into this point. So what am I trying to say is that the boy is generating, the boy is actually generating this line, generating the line. Okay, why? Because look, if the boy starts from A, then he walks to this point B, then he walks to this point 3, then he walks to this point 2, then he walks to point 4, then he walks to point 5 with some with from OA with some number lambda times AB times direction of AB. He can actually generate all of these points because he can have, what about if my lambda is 0.1? So that's going to be very tiny there. What about if my lambda is 10? So that's going to be beyond this line here. What about if my lambda is 3/4? Then it will be on the quarter, somewhere here, right? So what am I saying is that as long as this boy will follow these, then this boy will generate the line. Okay? The boy will generate the line. Let's try to generalize this. That's basically this one, basically. Okay? This one, OA plus some lambda times the vector AB is actually the equation of a line. Okay, that is an equation of a line. And let me just name it, for example, as line P. Okay, so the line P is equal to OA plus lambda AB. So wherein this lambda AB is the direction of the line, okay, and this OA is any point on the line, any point on the line. Please take note that it looks almost similar to the equation of the line y is equal to mx plus c, wherein in the Cartesian equation you have m as the slope. Okay, in the vector you need to find out what is the direction. Is there any given point? So if you know a direction and you know a point, then you can find the equation of a line. Let's try to have an example one on how to find the equation of a line. Let's say I have this point and the point is 1, 2, Let's not draw it anymore. And let's say this b is equal to negative 2, 4. Alright? So we need first a direction. We need direction. And what is the direction? Direction between the 2 point AB. So you just need to choose. Do you want direction AB or you want the direction BA? It's up to you. Anyway, they're gonna be parallel with each other. So let's say you want the direction AB, so therefore that is actually OB minus OA. Negative 2, 4 minus 1, 2. Then you will have vector AB is equal to negative 3, comma, is negative 3, 2. So this is now your direction. Okay, that is now your direction. So therefore now, what is now the equation of your line? Do we know any given point? Yes. There are actually 2 points, 1, 2, and negative 2, 4. So therefore you could have 1, 2, okay, plus lambda times your direction, negative 3, comma 2. And this is now the answer. That is now the vector equation of a line. Okay, so let's try to have another example, but this time let's take three-dimensional. Example 2, three-dimensional. I have a point A, and the point A is 1, 1, 1. I have my point B is negative 1, 0, 4. Okay, and remember this is in 3D space. Okay, so it's so difficult to draw the points or to locate the points. So we just need to imagine. So let's say this is your 1, 1, 1 A, and let's say this is your B. Okay, and what we want is to find the equation of that line. All right, and this is your origin. Okay, so you have this vector OA, that is your position vector OB. Again, what do we need? We need R, or I will use R. What is the one that's being used in the book? What letter? Yeah, okay, I will use R because it's the one that's written in the book. So the R is equal to any point, let's say OA, plus lambda of the direction AB. So what is your direction? Let's find the direction because direction is important. Direction now is OB minus OA, negative 1, 0, 4, minus 1, 1, 1. So therefore the direction now is negative 1 minus 1 is negative 2, 0 minus 1 is negative 1, 4 minus 1 is 3, like that. So now we have a direction. So therefore the R is equal to OA, any point. So 1, 1, 1, and then you have plus lambda of negative 2, negative 1, 3. Guys, please let me try to clarify this R. This R here is the position vector. I will write it in English so you would be able to follow that. The position vector of any, take a look at any point on the line. Okay, position vector of any point on the line generated, remember a while ago the moving boy, generated by a moving point. Take a look, generated by a moving point. Remember the boy, the boy was the point. So again, to complete the puzzle, so the R is the position vector of any point. So let's say this is that point. and this point is moving. Okay, that is moving. Where is the R? The R is this one. That is the R. So basically, when this P moves according to the direction AB, for example, okay? So this P, for example, moves here, moves there, moves in that point too. This R will shift there, okay? If the point P moves here, then this R, the position vector, will that be that point. So if the point P moves here, then this one, the R, will be that one. So that's the meaning of that R. The position vector of any point on the line generated by a moving point. Okay? Now, you might be wondering, this is not in your book, but then I just want to compare. In two-dimensional, you have a Cartesian equation of a line, Cartesian equation of a line in the form y is equal to mx plus c. In 3D, this is the vector equation, but there is also a Cartesian equation of 3D. Okay? There is also a Cartesian equation of 3D. But what is the form? Is it this form? No, it's not the form. So let me copy the answer here. So it's r is equal to 1, 1, 1 plus lambda and then -2, -1, 3. Okay? And we are looking for the Cartesian equation. This is a vector equation, VE, vector equation of a line. But what I want to show you, what's the Cartesian equation of a 3D line? So basically, you just need to replace, remember the R is the position vector of the moving point XYZ. Okay? So the R is moving to any point XYZ on the line. And that is equal to 1, 1, 1 plus lambda. And you have the vector equation, the vector direction -2, -1, 3. Right? So from here you can see that x is equal to 1 plus -2 lambda. That is this one here. Then the y is equal to 1 minus 1 lambda. Okay? And then the z is equal to 1 plus 3 lambda. So basically from here, what you're gonna see, if you this is already actually the vector equation or the Cartesian equation of a line, right? Or what you can do if you want, you can solve for lambda, okay? And the lambda gonna be equal to what? X minus 1 over x minus 1 over -2. The lambda here is equal to the second one, is equal to y minus 1 over -1. And then the lambda here is equal to z minus 1 over 3. So therefore, the Cartesian equation now will be x minus 1 over -2 is equal to y minus 1 over -1 is equal to z minus 1 over 3, which is your lambda, right? So this is the answer that what we're looking for, the Cartesian equation of a 3D line. While this one is the vector equation of the 3D line. Let's just summarize again. The general form of the vector equation of the line, I think I'll just take a point, just a generalization, okay? So let's say that there is a line here, and in that line there is a point here. Let's say that is point A. Sorry, that's point A. And then there is a vector. This is the vector direction, and I will name it as point P. I mean vector P, sorry. So the R, the vector R, the equation of the R is equal to, let's say that is the origin, is equal to OA, okay, OA, but I just want to use the notation vector A, okay, is equal to the vector A plus any multiple of my direction P, okay. This is now the vector equation of a line. Vector equation of a line, wherein A is the position vector of any point on the line, while P is the direction of a line, okay? And lambda is a scalar, where lambda belongs to the set of all real numbers, because it can be a positive number, it can be a negative number, it can be a fraction, it can be a decimal, it can be a radical, okay? So that's why it belongs to real numbers. So that's end for this video. The next example, I'll take some papers, I'll take some questions from the past papers, so you'll be able to see how is this concept being applied in the real exam. Thank you.